Hello, good morning. This is Marilyn C. Today we're going to have a tutorial for the continuation of our organic chemistry, which is for today's chapter 2. Before we're going to have that tutorial of the chapter 2 of organic chemistry, let me remind you of how you can access of your work exercise. Now this time, because I am new to this channel or to this tutorial as well, I am still adjusting, so bear with me for whatever developments that I am going to make. And for this time, I have found out that it is more easier for between the two of us. If you want your work exercise, I am going to send it to you through in a test or in a form of a test paper. So send you $1 to my PayPal account. I'm going to put a link on at the comment section for my PayPal account link, as well as my email address, so that after you sending your $1 to my PayPal account, meaning that you want to purchase a work exercise, send an email to me stating that you had already sent your $1 to my PayPal account. Then I'm going to send you work exercise right away. Then after you have worked on with your work exercise, send your work exercise to me, back to me, so that I can check it. And after me checking your work exercise, I'm going to send that back to you with your scores, as well as the corresponding explanations to each of the questions that I'm going to put into your work exercise or the test paper. Alright, so much for that. Let us continue or proceed to our tutorial, because we have a lot to talk about and I don't want to waste your time, because 1 hour is not enough and I can only cater 30 minutes for our tutorial for every session. All right, so today we're going to discuss about hydrocarbons. This is the chapter 2. We're going to talk about hydrocarbons. What is hydrocarbons? Hydrocarbons is a compound that contains only 2 elements. And what are those 2 elements? The hydrogen and the carbon elements. So, and under with the hydrocarbon compounds, this is chapter 2 of our organic chemistry. And under with the hydrocarbon compounds, we have 2 subtopics. What are those 2 subtopics or hydrocarbon compounds? Are the aliphatic hydrocarbon and the aromatic hydrocarbon. What is an aliphatic? First, we're going to talk about aliphatic hydrocarbons. What is an aliphatic hydrocarbons? Well, for the aliphatic hydrocarbons, this is an open chain structure aliphatic hydrocarbons. Aliphatic hydrocarbons has 3 compounds. What are those? First is the alkanes. If you can still recall, in our chapter 1, we talk about 3 aliphatic hydrocarbons. Those are the alkanes, alkenes, and alkynes. So today, first, we're going to talk about alkanes. Before I'm going to introduce it to you, what are the alkane hydrocarbon compounds? Let me give you or present this to you, the 3 forms of alkane compound, hydrocarbon compounds. First is that if the formula of your alkane compound has this number of carbon atom from 1 to 4, they are in a form of gases. These compounds are in a form of gases. Now, if your hydrocarbons has a carbon atom of starting from 5 to 15, they are in a form of liquid. If a carbon atom has 16 and above, they are in a form of solid. Now, how to name or nomenclature for these alkane compounds? We have 3 namings, or the basic system of naming the aliphatic or the alkanes aliphatic hydrocarbons. First is we have this common name. What is the common name? Is just a common name of naming the alkane compounds. And the second way of naming an aliphatic alkane hydrocarbon compounds is the derived system of nomenclature, and the third system of nomenclature is IUPAC system. What is the meaning for an IUPAC? This is an international, for IU is the International Union of Pure and Applied Chemistry. Now, what is an alkane? I said first compound under with the aliphatic hydrocarbon is an alkanes aliphatic hydrocarbons. What is an alkane aliphatic hydrocarbons? They are saturated hydrocarbons. What is a saturated hydrocarbons? Structure for the alkane or the saturated hydrocarbons is a single bond, present of a single bonds between the carbon atoms. And they are also, alkanes are also called as paraffins. do you still recall the general formula of your alkanes in our chapter 1? That the general formula for the alkanes is CnH2n plus 2. Now we have this one. Wait a minute. Okay, what are the alkane compounds? Alkane compounds. We have this. Can you see? Okay. The alkane compounds are the first compound under with the alkane is called methane. So what does that mean? With the prefix met, meaning the structure formula has only one carbon atom. So the structure is letter C, only one carbon atom. Follow the general formula of alkane for you to be able to get the structural formula of your alkane compound methane. You have Cn, only one carbon atom, Cn, C1 carbon atom, H2 times the number of carbon atom, where N is your number of carbon atoms. So C2 times 1 is H plus 2 is 4. So CH4 is the structural formula for your methane alkane hydrocarbon compounds. And what about the graphical formula? So you have only one carbon atom, right? Only one carbon atom, and you have 4 hydrogen atoms here. Again, in our chapter 1, you are going to satisfy with 4 covalent bonds in every of your carbon atoms. So you have 4 covalent bond here now, 1, 2, 3, 4, and to the other end you write hydrogen atom. Why hydrogen atom? Because this is under with hydrocarbon compounds, and again hydrocarbon compounds has only 2 elements, those are the carbon and the hydrogen. Now the next compound under with the alkane is called ethane. The prefix is eth, meaning 2. You have 2 carbon atoms into the formula for the alkane ethane compound. So you have 2 carbon, and what about hydrogen? How many? Follow the general formula. So C2H2 times 2 is 4 plus 2 is 6. So C2H6. What about the graphical formula? So it says here 2 carbon atoms. So you write 2 carbon atoms, 1 and then 2. And then for every carbon atoms, you satisfy them with covalent bonds, 4 covalent bonds. So yes, 1, 2, 3, and 4. For this carbon atoms, you have 1, 2, 3, and 4. And to other end of every covalent bonds, you have assigned them with hydrogen atoms. Okay, you cannot assign hydrogen atoms for this covalent bond because these 2 carbon atoms are sharing for this covalent bond here, right? The next compound, alkane compound, is called the propane. You have the prefix prop, meaning prop, you have 3 carbon atoms, so 3. And what about the number of hydrogen atoms? How can we derive or solve for the total number of hydrogen atom present into this alkane compounds propane? Yes, follow the general formula again. So you have C2 times the number of N, which is the number of carbon atom, is 3C. 2 times 3 is 6 plus 2 is 8. So we will, what is the graphical formula, right? 3 carbon atoms, 1, 2, and 3, and then 1, 2, 3, 4 for the 4 covalent bonds. And what about for this carbon atom? You have 1, 2 already, so you write 2 more. And then what about for this carbon atom? The covalent bonds are 1, 2, 3, and 4, and then you assign hydrogen atom to each end of that covalent bonds. Now the next is butane alkane compounds. But, the prefix name but is called that this the formula for butane has 4 carbon atoms. And what about the number of hydrogen atom present into this compound butane? Let us follow again the general formula, which is H2 times the number of N, which is the number of carbon atom, is 4. 2 times 4 is 8 plus 2 is 10. So therefore butane has a structural formula of C4H10. What is the graphical formula for butane? If you have the structural formula C4H10, it is 1, you draw again 4 carbon atoms, and then satisfy each carbon atoms with 4 covalent bonds. So you have 1, 2, 3, 4. What for this carbon atom? 1, 2, 3, 4. And the next carbon atom 1, 2, 3, 4. And the last carbon atom 1, 2, 3, 4. And then again you assign each of other end of that covalent bonds with hydrogen atoms, right? So as easy as that. Now the last is pentane. The prefix pent meaning into that structural formula, the total number of carbon atom we have is 5 carbon atoms. So what about the hydrogen? Again, follow the general formula, which is H2 times N is the number of carbon atoms, which is 5 is 10 plus 2 is 12. So, yeah, it's okay. So 2 times 5 is 10 plus 2 is 12. Alright. For the pentane has this structure formula C5H12. What about the graphical formula? So again, you write number of 5 carbon atoms, 1, 2, 3, 4, 5, and to each carbon atom assign them with 4 covalent bonds, and same thing until the end. You have to put them with 4 covalent bonds each, and then at the other end of that covalent bond assign them with hydrogen atoms. Okay, so you get now the idea on how to solve for the structure formula and as well as the graphical formula for the alkane compounds. Again, if you have 1 carbon atom, the name of the alkane compound is methane with a prefix met, and then if you have 2 carbon atoms, prefix is F, and if you have 3 carbon atoms, the prefix is prop, and if you have 4 carbon atoms present to the alkane compound, the prefix is but, as well as if you have 5 carbon atoms, the prefix is pent. And also take note of what are the suffixes. Alkane, the suffix of the alkane is A and E. Therefore, the compounds under with the alkanes must also have the suffixes A and E. And what about if you have 6 carbon atoms present into that structure? What is the name? If you have 6, the prefix is called Hix. And then A and E under with the alkane. So how many carbon atoms? You have 6. And then you have the 14 hydrogen atoms, and this is the graphical formula. Same process as what we did with the methane, ethane, propane, butane, and the pentane. To this following the remaining 5 more alkane compounds so far that we are going to discuss right now. But later on, if we have more of that, so we can name them on sometime. All right, so continue. If you have 7 carbon atoms present in the structure of your alkane compounds, what is the prefix? Is hept. And this is the suffix A and E under with it, meaning this is under with the alkane. So what is the structural formula? Carbon atom 7, and then hydrogen atom you have 16. Following again with the general formula CnH2n plus 2. That's why you have 16 for the hydrogen number of hydrogen atom present into the heptane alkane compounds. And what is the graphical formula? You're going to write 7 carbon atoms first, and then for each of the carbon atoms you satisfy them with 4 covalent bonds, and the other end of that covalent bond you have to satisfy them or assign them with a hydrogen atom each. And what about if your alkane compound has 8 carbon atoms? The prefix is oct. The prefix is oct. And what is the structural formula? So again, if it has oct, meaning it has 8 carbon atoms. And what about the hydrogen atom? It has 18. And so this is the graphical formula. Same also if for the next alkane compound, if your alkane compound has 9 carbon atoms, what is the name? The prefix is non, meaning 9 carbon atoms present to the structure. And following the general formula as to how are we going to arrive for the total number of hydrogen atom present into the non-named alkane compounds is CnH2n plus 2. So you have the 20 here. So C9H20. And what about the graphical formula? This is the structure of graphical formula. Same process as what we did before. And then the last of my example here is if your alkane compound has 10 carbon atoms, what is the prefix? Is dec. And then as to how many hydrogen atoms the decane, meaning A and E suffix, this is alkane, how many hydrogen atoms present to this compound is following the general formula CnH2n plus 2. So therefore you have total number of 22 hydrogen atoms present into the decane alkane hydrogen compound. So, and this is the graphical formula. Okay, so that is so far for the alkane compounds. And the next is if we have alkane, we also have this so-called alkyl radical. What is an alkyl radical? These are only groups of hydrocarbon compounds that is only a group that cannot stand without the main structure. So this is only a branch or a group that cannot stand alone without being attached to the main structure. So what is that group? It's called Alkyl Radical with a representative of letter R compounds. What is the general formula of alkyl compound? Is NH2n plus 1. So this is only plus 1. In your alkane with a suffix of A and E is plus 2, while your alkyl has only suffix of YL has only a plus 1 as its general formula. So again, if you have noticed that our prefix is the same as with the alkane, that if we have a prefix of met, meaning that met, meaning it has only one carbon atom, it's into its formula. So that's why we have C, only one carbon atom. And since we're talking about alkyl radical compounds, so therefore take the suffixes of YL into that name of compound. So we have the met as prefix, meaning one carbon atom, and the suffix YL, meaning this is under with alkyl radical. So, and following the general formula for you to be able to compute for the total number of hydrogen atom present into its structure. So CnH2n plus 1, that's why we have this 3 atoms of hydrogen. 1 atom of carbon, H2 times 1 plus 1 is 3, right? And the graphical formula, this is the graphical formula. Your carbon atom must have 4 covalent bonds again, but into the alkyl group, since you have only 3 hydrogen atoms, you have only in the graphical formula can see 3 hydrogen atoms, but always retain this unpaired covalent bond, because meaning of this is this bond is ready to be connected to the main structure, because again this is only a group or a branch that cannot stand alone without attaching to the mother chain or the mother structure. Okay, we will talk about that in a later discussion of our today's topic. Okay, so again, if you have a prefix of et, meaning the number of carbon atom present to that compound has 2 carbon atoms, and YL is follow the general formula, say n HN2N times 1 is plus 1 is 5. So your ethyl alkyl radical compound has a structural formula of C2H5. And what about the graphical formula? Is you have 2 carbon atoms and 5 hydrogen atoms. So the same system that we are going to follow as to how are we going to draw the graphical formula for every alkyl compounds. But what differs this with the alkane compound is that it lacks an unpaired. You always have an unpaired covalent bond, meaning these structures are ready to bond to the mother structure, the main structure. Okay, so you have this prefix prop, meaning 3 carbon atoms. You have 3, and the YL under the alkyl radical compounds, but this is why you have only 7 instead of 8 in the alkane, right? So the same thing as with your butyl, you have 4 carbon atoms. Pentyl, you have 5 carbon atoms. And then what about if you have 6 carbon atoms? What is the prefix, no? If you have 6 carbon atoms, prefix is hex. If you have 7 carbon atoms, you have the prefix hept. You have 7 carbon atoms. If you have 8 carbon atoms, the prefix is oct. And if you have 9 carbon atoms, the prefix is non. And if you have 10 carbon atoms, the prefix is dec. And you have the suffixes YL. And this total number of hydrogen atoms, how we arrive all of this total number of hydrogen atoms into its structure for this alkyl radical compounds is follow the general formula for the alkyl radical compounds. Okay, and for the graphical formula, follow again the system of how we arrive into making of its graphical formula. And take note again, don't forget about this unpaired covalent bonds present for each of these alkyl radical compounds for their graphical formula. Next is we have how to name the nomenclature and the writing formula of the hydrocarbon compounds. First nomenclature is called common or trivial name. Now there are 3 systems on how to assign a common or trivial name for an alkane hydrocarbon compounds. First is the so-called N. What is N? Normal. Now for example, if we have this kind of structure, CH3, CH2, CH2, CH3, And how many carbon atoms do we have into this structure? You have 1, 2, 3, 4, 5. And this is a straight chain, right? So if you have a straight chain, the prefix is N. That's why you have this N for the common name, N, meaning if the name of that structure starts with letter N, meaning automatically that compound is normal. What is normal? That the structure is straight. Okay, normal, straight, having a straight chain of the carbon atoms. So that's why you have N. And then total of 1, 2, 3, 4 carbon atoms. If you have 4 carbon atoms present into the structure, what is the prefix? Is but. And what type of bond present into this structure? Is a single bond. And if it has a single bond, meaning this is alkane. What is the suffix of the word alkane? Is ane. That's why in your but prefix, your suffix is ane, butane. Meaning butane, ane, you have a single bond. But, you have 4 carbon atoms. And meaning your structure is straight. Okay, the second way of naming your system of naming your alkane compounds is with a prefix so-called iso. Meaning of the iso must have an L shape, either this shape, or this shape. And for example, if we have this structure, so iso, we have an L shape here, you have an L shape here, only those, okay, or going this way or going this way, they are still an L shape. So automatic, if you can see this kind of structure that you can have this L shape, your prefix is iso. And for your mother chain, what is a mother chain or the main structure? Is a structure that has a longest continuous chain of the carbon atoms. So if we go this way, you have 3 carbon atoms. If we go this way, also another 3 carbon atoms. In all ways, you always have 3 carbon atoms, and therefore automatic, the number of carbon atoms present to your main structure, your mother chain, has a total of 3 carbon atoms. If you have 3 carbon atoms for your structure, what is the prefix? Is prop. And what type of bond do you have in this structure? Present to this structure is a single bond. And what is the suffix? If you have a single bond, is a suffix is ane. So meaning this is under with the alkane compound of the aliphatic hydrocarbon. So you have the propane, prop meaning 3 carbon atom of your main structure, suffix ane meaning you have that type of bond is a single bond. And then as you can see that in this green ink here, you have group or branch attached to your main structure. And what is the name of that group? Recall your alkyl radical compounds. This CH3, this is only 1 carbon atom. That's what is the prefix? Is met. And you have only 3 hydrogen atoms. This is alkyl radical attached to the main structure. So what is that? Name of an alkyl radical compound is methyl attached to the second carbon atom, right? Okay, so what's the name of this group or branch attached to your main structure? Is a methyl group. So you have an L shape, prefix is iso. And then name the following, name the next, how to name the, to give the complete name for this structure. The next one after having a prefix iso is locate or check your structure whether there is other group other than the main structure. Again, what is our main structure? Is this continuous chain of your carbon atom having 3 carbon atoms. And this one is your branch or group. What is the name of your branch or group? Is the next after the iso is methyl. Why methyl? Because you have only 1 carbon atom, therefore the prefix is meth. Why YL? Because you have only 3 hydrogen atoms present in this branch or group. So this is alkyl radical, so methyl. And again, the name of our main structure is propane. So to name this whole structure is called iso, meaning IL shape. And then methyl, this is the branch, the group that attached to your main structure, which is methyl group. And then the name of your main structure or the mother chain is propane. So isomethyl propane is the name for this structure. And another way of giving a common name to the alkane aliphatic hydrocarbon compound is so-called neo. What is neo? If you can see into the structure, a T shape. What is a T shape? You can see that one, continuous chain of your carbon atom, and also this one is another continuous chain of a carbon atom. So that is T shape. If you can see this T shape, then the prefix is neo. Same thing as with your iso. right away put the word neo as your prefix, and then after that check whether your mother chain has how many carbon atoms. What is that mother chain? Is you are going to check the structure for how many carbon atoms do you have that has a longest continuous chain of the carbon atoms. So if we go this way, we have only 1, 2, 3 carbon atoms, and if we go this way, also same number of carbon atoms, 3. So let us go this way as is the easiest way to identify. Anyway, they're all in anyways same number of carbon atoms. So let us just have this as our mother chain. Okay, having 3 carbon atoms. 3 carbon atoms, the prefix is prop. And what type of bond we have present to this structure is a single bond, therefore our suffix is A. So the name of the mother chain is propane. And then after identify your mother chain, what are other groups attached to your propane? You have this one and the other one. And what is the name of those groups or branches that attach to our mother chain or mother structure are the 2 methyl groups. And if you have 2 groups attached, the same groups attached to your mother chain, how do you name them? It's called di because it is 2. You have a prefix word di. And what are those name of the 2 groups is methyl. So to name the structure is called neo-dimethyl propane. Neo having the T shape, di having the same groups or branches attached to your mother chain. What is that? 2 same groups attached to your mother chain are the methyl groups. And then what is the name of your mother chain is the propane. So neo, T shape, di, 2 same groups, methyl group, and the name of the mother chain propane. Another way, another system of naming the alkane compounds is called a IUPAC name. So how to identify an IUPAC? How to give an IUPAC name to an alkane compounds? First is that you are going to find the longest continuous chain of the carbon atoms as what I have said and assign that as your mother chain, okay, or your parent chain or the mother structure, whatever. So mother chain, parent chain, they're just the same, all right? And assign that as your parent chain. Find the longest continuous chain of the carbon atoms and assign that as your mother or parent chain. So for example, if we have this structure CH3, CH2, 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 CH3, then therefore how many carbon atoms do we have into this longest continuous chain of a carbon atom is 5. So if we have 5 carbon atoms present into the structure, so what is our prefix is pent, 5 pent, right? And the type of bond present in the structure is a single bond. If you have a single bond, what is our suffix? ANE under alkane, right? So therefore pent, 5 carbon atoms, single bond, ANE. So the name for this structure is pentane. Then following, after finding the longest continuous chain of your carbon atom and assigning it as your parent name, you are going to find whatever group or groups that are not part of the longest continuous chain and name them as your prefix, okay? Aside from, for example, into this structure. So what is our longest continuous chain of the carbon atom into this structure? You have CH3, CH, CH2, CH2, CH3. And how many carbon atoms do we have for this longest continuous chain of the carbon atom? You have 5. What is the prefix if you have 5 carbon atoms spent? And what type of bond that you have present to this structure is a single bond, meaning the suffix that we are going to attach to our prefix pent is ANA. So therefore, the name, total name of our parent chain or the mother chain is pentane. Then after that is you are going to check whether there is a group of bonds that attach to your parent's chain or the structure. Yes, in this case we have 1. And what is it? Is the CH3. What is the name for CH3? Only 1 carbon atom. What is the prefix? Is met. And then this is having, you are having 3 only hydrogen atoms. So meaning this is alkyl radical. So what is the name of that compound? Methyl. Attached to your mother chain, what's the name? Your name of your mother chain is pentane. Therefore, to name the structure, this is methyl name first as your prefix, that branch or group that attached to your mother chain, methyl, and then followed by the name of your mother chain, pentane. So methyl for that group attached to your mother chain, pentane is the name of your mother chain. And then next, after finding these other groups that are not part of the longest continuous chain, and this one is our prefix, and in this case we have the methyl, the next is that you are going to assign numbers to groups by counting from one end, starting from the nearest end that has a group or groups that is not part of the mother chain. So what does this statement means? For example, into this example structure, if we in our structure, the longest continuous chain of a carbon atom, we have 5 carbon atoms, and check what are the groups that is not part of the mother chain. We have this one, the CH3. This is the branch that attached to your mother chain, and you are going to assign numbers. We have 2 ends. Which end is our first carbon atom? This end or this other end? You check your other group or the branch that attached to your mother chain. What end is nearest that group to? So in this case, this methyl group is at nearest to this end compared to the other end. Therefore, we are going to assign our first carbon atom into this end. So that's why we have our first carbon atom here. They have second, third, fourth, and the fifth. So since your methyl group, to name now the structure, since your methyl group, this is what we are going to use as our prefixes. Since your methyl group is attached to the second carbon atom, then therefore you're going to say 2, meaning this is the group, the carbon atom where is attached to, dash, because the number between a number and a name, you're going to separate them with a dash. Okay, so dash the name of the group that is attached to the second carbon atom, and in this case we have the methyl group, and then followed by the name of your parent chain, which is pentane. Why pentane? You have 5 carbon atoms. Why has a suffix of A? Because the type of bond that we have this into our mother chain structure is a single band. That's why we called it pentane. Now the next way of naming your IUPAC system for your alkane compounds is that if there are 2 or more identical groups, so for example, not only 1 but there are 2 or more identical groups, the same group, we are going to use prefixes. What are those prefixes? So we have, if you have 2 the same group, we have a prefix a di. If we have 3 the same groups, a prefix of tri. If we have 4 the same groups, prefix of tetra. If we have 5 the same groups, a prefix is penta. If you have 6 same group, the prefix is hexa. For example, in this structure, we have 2 the same groups attached to our mother chain. So what is our mother chain? A longest continuous chain of the carbon atoms. So in this case, we have how many carbon atoms that is in our mother chain? The longest continuous chain of the carbon atom is 5 carbon atoms. What is the prefix if you have 5 carbon atoms? Is pent. And what type of bond that is present into our mother chain is a single bond, and therefore our suffix for the name of our mother chain is ANE. So what is the complete name for our mother chain is pentane. Now next is that what are our prefixes? Our prefixes is to identify what are these groups or branches that attach to our mother chain, and in this case we have 2 the same groups. What are those? This group and the other one. They are the same groups. And what is the name for those 2 groups? The same 2 groups. You have only into this structure, you have only 1 carbon atom. So therefore, what is the prefix if you have 1 carbon atom? Is met. And then this is having 3 hydrogen atoms present in the structure, meaning this is an alkyl radical group of a compound. So, and attached to the second carbon atom. Why our second carbon atom is nearest to this end? It's because these 2 the same groups is nearest to this end rather than into this end. It's farther, right? So we consider always to the end we're in our groups or branches is attached to nearest to that end. So 1 is our first carbon atom into this side. Okay, now to name the structure. First is, what are your prefixes? Is the location of your groups or the branches. Our branches is this one and this one. They are identical and they are attached to the same number, second carbon atom. So therefore, to name the structure is 2, meaning this group is attached to the second carbon. And since you have also the same group attached to the same carbon atom, so comma, to separate 2 numbers, you have to 2, comma, 2, meaning 2, comma, 2, di. Why prefix di? Because we have the same group, methyl group, you have di, and then the name of these compounds, the branch, the groups is methyl, and then followed by your suffix, the name of the mother chain. And the other way of naming the IUPAC system of your alkane compound is if there are 2 or more different groups, we put them into the prefixes in alphabetical order. Different, remember, different groups. This one is identical. Now in this time, what about if into your structure you have 2 or more different groups? For example, into this structure, we have how many carbon atoms present into our mother chain? Again, 5. And other than these 5 carbon atoms, the longest continuous chain of our carbon atoms considered as our mother chain, we have 2 different groups attached to the same number of the carbon atoms. Why? We have assigned this side because again these 2 branches or groups are attached to nearest to this end. Therefore, our first carbon atom is in this side, right? So, and to name the structure now is our prefixes, the groups first, located or they are attached at what carbon atom number of our mother chain. They are attached to the second carbon atom. That's why, and then since they are of different groups or branches name of a compound, then therefore follow the alphabetical order. What comes first, the B or the M, the bromine or the methyl? The B comes first in the alphabetical order, followed by the methyl. So we will name this bromine first, but we don't name them as bromine, we name them as bromo. Same thing as with your chlorine, chloro, iodo for iodine, fluoro for fluorine. Okay, so your bromine, your bromo attached to the second carbon atom. That's why you have this 2 dash. We have to write dash if you're going to name the structure that is in between a number and a name. But if you are going to name a structure in between 2 numbers, you're going to use comma, right? Okay, in this case we use dash. 2 dash bromo, so meaning your bromine is attached to the second carbon atom. 2 bromo, and then dash 2 methyl for this group, and then the name of our mother chain, the main structure. And the last way of system of naming in under a IUPAC system for your alkane compound is if we have 4 halogens. This is what I have said. For fluorine, we call them as fluoro. For chlorine, we call them as chloro, not chlorine. The same thing as for your bromine, bromo, iodine is iodo. Now another kind of alkane compound is called cycloalkanes. If you have an aliphatic, meaning open chain structure, okay, and cycloalkanes meaning closed chain structure. What is an cycloalkanes? We may begin at any position and may proceed either clockwise or counterclockwise, but we must end up with the lowest possible numbers. What does this meaning meant about the cycloalkane description for the naming of the structure of your cycloalkanes? It means that, for example, if we have this example right here, that okay, if we have this closed ring structure, the branch or the group attached to this first corner, meaning this is your first carbon atom. So you have methyl, and then since this is a